Have you seen The Ghost of Tom? 4.6 HL and Isosceles theorem. Let's see what those are going to be talking about. So the HL theorem stands for hypotenuse leg congruency theorem. This is the fifth and final theorem for when you are showing that two triangles are congruent. The first one was side, side, side. Show that all sides are equal. The second one was side, angle, side. The third one was angle, side, angle. The fourth one was angle, angle, side. And this is the final one, the fifth and final hypotenuse leg theorem. All right. The theorem says if the hypotenuse of a leg of a right triangle is congruent to the hypotenuse and the leg of a second right triangle, then the two angles are congruent. So the key word here is a right triangle. Whoa. So this theorem only works with right triangles. And so if it is a right triangle, and then the hypotenuse and leg match up, when we have that, we use the hypotenuse leg theorem. All right, so if it has to be a right triangle and the hypotenuse has to match up and one of the legs has to match up, then we use HL theorem. All right, let's do a few examples. Let's look at these two triangles. Again, the two triangles are squished together, so it tries to confuse you. But let's see. We have, it looks like a right angle, so that's good. And then we have the hypotenuse, and then we have the side it shares. All right, so I think it qualifies. So you have a right triangle, you have the hypotenuse, and you have one of the legs, and the one of the legs they share. So yes, this is congruent. Here's another example. We have an angle, but it's not marked a right angle. We have a side. And then since this looks like a hypotenuse, but since we don't have a right triangle, it's no longer called the hypotenuse. It's just another side. And so if I put in another S, it'll spell a bad word. And so that's when you know it doesn't work, is then you have angle, side, side. It spells a bad word. It's not a right triangle, so it's no good. So this is not those two are not congruent. All right, let's have another theorem. Now this theorem doesn't have to do with comparing two triangles. This is just a brand new theorem, and it's based on just one triangle. Base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. All right, so it's this isosceles triangles. You have two sides are the same. When that happens, then the angles across from them are going to be the same. So that's why it's a base angle. If the two sides are the same, then the two angles are the same. So we have BAT, B-A-T, base angles theorem. Two sides are the same, two angles are the same. Let's see how we can use that. Oh, there it is. If AB is equal to AC, let me erase some of that stuff. If side AB is equal to side AC, then the angles B and C are also equal. All right, so let's do a few examples using that theorem. Well, here we have the same picture. The two sides are the same, which means these two angles are the same. So x is 31. Well, then how do you find y? Well, using another theorem, the triangle sum theorem, all angles inside a triangle must add up to 180, remember that. Well, if we subtract 31 and 31 from 180, we get 118. Clearly, this triangle is not drawn to scale, but that's fine. Here's another example. Notice the two angles are the same. What does that mean? That means that now the two sides are the same. Oh, so we can set them equal to each other, use a little bit of algebra, and you should get x equals 2. All right. This one says tricky. Ooh, solve for x and y. Why is it tricky? All right, so same picture. Now I'm just laying it down sideways. We have an isosceles triangle. That means that these two angles are equal. But that doesn't really help us because if we set them equal to each other, you're going to have 2x minus 5 equals y plus 50. You're going to have an x and a y in the equation, and you cannot solve it when there's two variables and only one equation. Okay, so how do we do it then? I'll give you a little hint. It has to do with this 26 degrees. Well, you're going to use the triangle sum theorem. This angle plus this angle plus this angle, all three of them have to add up to 180. Well, if this is already 26, that means these two have to be 77. How did I do that? I took 180, I subtract 26, 180 minus 26 is 154. So I know that I have to take that 154 and I split them up evenly by 2 to get 77 on each angle. And then from there, you just set the y plus 50 equals to 77, solve it out, and then set the x, 2x plus 2x minus 5 is equal to 77, and then solve it out. And you should get x equals 41. So that was a little bit tricky just because there were a lot of ways to set it up, but then only one way that would work. All the other ways you set it up, even though they're correct, they don't help you set up, they don't help you solve the problem. All right, here's an extension of the base angles theorem. So the base angles theorem was if the two sides are the same, then the two angles are the same. Well, what if all three sides are the same? Then obviously all three angles are the same. Not only are they all the same, they're all 60 degrees. Okay, let's do one last example to show how this theorem works, and then we'll be done. Solve for x and y. So it turns out that all three sides are the same, so you just see, oh, how do you set all three equal to each other? You don't set all three equal to each other. You just set two at a time. So let's do these two first. 8 equals 2x minus 10. So add 10 to both sides, divide by 2. There it is. Now let's go ahead and set these two equal to each other. 8 equals 1/2 y. To solve for y, you multiply both sides by 2. Multiply both sides 2, be tricky about that one. All right, and then you have 16. All right, that is all we have for today. Go ahead and try the homework.